Thank you for, first of all, thanks for MITS Radio for giving this wonderful opportunity. In this session, I'm going to discuss about statistical inferences. So, first of all, let me define what is statistics. So, statistics can be defined as a data which can be converted into a meaningful numbers. A data means a raw numbers which doesn't have any meaning. But statistical is a science, mathematical science, which converts this data into meaningful numbers. So, we can say that data, by using statistical analysis, can be converted into meaningful insights. So that is the purpose of statistics. So statistics can be of two types. First one is descriptive statistics, and second one is inferential statistics. So descriptive statistics is nothing but the name itself indicates this descriptive statistics describes the data. That's it. But whereas coming to statistical inferences, by using some statistical tool analysis, we can predict the future. So out of these two, both, although both are important, but statistical inferences is somewhat more important and analytically more concept wise, analytically more important, this statistical inferences. So now we are going to discuss about what is statistical inferences and basic concepts which are related to statistical inferences. So statistical inferences or inferential statistics is nothing but predicting the future by using the samples of the population. So for example, in the most important concepts which is related to inferential statistics is population. So population is nothing but the total number of people or the total number of items which are under our observation or which are under our experiment is termed as population. In this population, as we know that we cannot do the experiment to all the observations or to all the items in the population, right? So obviously we need to, of course, the cost and the time will be the constraints for doing experiment on all the observations. So in order to reduce the cost and constraints, we sample, we take the portion of the population to our experiment. So the portion of the population which is taken for our experiment is termed as sample. So sample is nothing but the portion of the population which is taken from the population itself only. Say for example, I want to measure the height of all the AP students who completed their 10th class. So all the 10th class students who are in AP will be termed as population. And if I pick some of the students, few people from, say for example, Madanapalle region, and for example Telangana region, or for example if I pick some few people from the different parts of Andhra Pradesh, that constitutes sample. So that is the difference between sample and population. So now next we are going to discuss about what are the sampling methods. So sampling methods are of two types. So first one is random sampling, and the second one is non-random or judgmental sampling. So what do you mean by random sampling? In random sampling, we randomly pick the items or observations from the population. So there is equal chance, equal probability or equal chance of picking the observations. So in random sampling, we don't have any preconceived ideas to pick so and so sample or so and so observation. We blindly randomly pick the samples from the population. So that type of sampling method will be termed as a random sampling method. Whereas coming to non-random sampling or judgmental sampling, we have a preconceived idea about how to pick the samples. So we say, for example, I want to pick the height. For example, I want to measure the height of the students who are from AP, who completed their 10th class. Say for example, I only specified or focused on Madanapalle region. Why? Because my convenience is there. So I am living in Madanapalle region. So because of my convenience, the sample for this experiment maybe I choose only for the students who are from Madanapalle region. So I didn't pick the random methodology, or I haven't used any random methodology. I am focused based on my preconceived and convenience. So this type of sampling method is known as random or judgmental sampling. So these two are the most important concepts in the statistical inferences. Now another important thing in statistical inferences is hypothesis. Hypothesis. So for example, if assume that you're driving a car during night time. So you drive the car by switching on the lights. So lights will provide a proper direction in the way in which you have to move. Say assume that there is no light. So obviously in the night time, if there is no light for the car, obviously we will move in random directions without any proper idea about where we are going. So on similar, so lights provide a proper direction for the movement of the car to reach the destination. On the similar lines, hypotheses provide a direction. Hypothesis is nothing but an imaginative or assumption or assumptive statements which moves our experiment in a proper direction. So hypothesis is of two types: null hypothesis, and the second one is alternate hypothesis. So null hypothesis will shares that the null hypothesis is also an imaginative statement which states that there is no relationship between the two variables, as null indicates no relationship. So the statement which indicates there is no relationship between two variables will be termed as null hypothesis. Whereas alternative hypothesis is quite opposite to null hypothesis, which states that there is some relationship between the two variables. So before doing any experiment which is related to statistics or whatever it may be, we have to frame the hypothesis, both the hypothesis statements, which is nothing but null hypothesis as well as alternate hypothesis. So this is about today's session, and thanks for giving this wonderful session, and thanks for giving this wonderful opportunity from MITS Radio, and thank you, sir.